Hi, everyone. My name is Michael Cantu. I'm a solutions engineer for GitHub, and I'm here today to talk to you about how GitHub builds GitHub using GitHub, right? I'm really excited to be here and to share this story with you guys. Right. Let's go through. All right, so for those unfamiliar with GitHub, GitHub has built our platform through our experiences with millions of developers, thousands of open source communities, thousands of enterprise customers. In fact, 72% of Fortune 50 companies use GitHub. We have over 65 million developers today using GitHub globally, and more than 3 million organizations, right? So this can range everything from individual maintainers with free public repos to thousands of developers using, DoD via GitHub Enterprise, which is available on-prem in a public cloud, or often we get this question: how does GitHub use GitHub, and how do we build software? It's an interesting question from both a general curiosity and interest in how we work internally. It's awesome to think about how we use GitHub and figure out, how we can put this in a presentation, right? Since we're always evolving, we're constantly evolving, we're always experimenting and trying new different things. So as GitHub continually evolves and continues to improve and experimenting, at its core, however, we really focus on these 4 pillars, such as common philosophy, asynchronous communication, chat ops, continuous delivery, both past and present. So let's dive deep into each pillar one at a time. And first up is common philosophy. So the core of the core philosophies and ideas are part of Zen part of the Zen of GitHub, which can be queried at api.github.com/octocat. And as you can see here, the Zen of GitHub within our terminal, a lot of them is they're far too long to go through, but the gist of it here, what really speaks to it, is the non-blocking is better than blocking, right? Also speak like a human. Approachable is better than simple. It's all about being human, right? To be able to speak to a developer, to another teammate, and really voice your concerns, but be as empathetic and approachable as possible, right? Non-blocking is better than blocking in this scenario. And with that said, we can dive deep into asynchronous communication. So this is a slide. This picture's from 2016 most likely, and it showed that even back then we were still a remote first company. But as we grow, how do we maintain asynchronous communication, especially around writing software, right? So, and this is a picture from August 2021. As of today, right? Almost at the time of this recording. So as we grew, how did we maintain asynchronous communication? Sure, we have tools such as Slack, Zoom, Teams, but how do we maintain asynchronous communication for software development? And in reality, it all starts at our core of issues in communication, documentation, and source code, right? So if you haven't seen this before, this workflow is called the GitHub Flow, and the gist of it is that you have a master branch or a main branch. And what is a branch, right? A branch is essentially a unique set of unique branch with a unique name with a unique set of code, and it's very lightweight, most often used for development and new features. So in this case, if I wanted to make a modification or add some sort of a new feature to this application or to this project, instead of directly pushing changes to production, right? Pushing changes directly to main, you would create a new branch and then push those changes via commits, right? So by creating a new branch, we're basically creating a parallel workflow or a parallel a branch where we can make any modifications and changes without affecting our production environment, right? So as we've added those commits, we entered the pull request phase, and the pull request really is a focal point of everything that goes on in GitHub. It's a crucial phase where we can reveal and discuss code, bring an idea to life, as well as talk about integration and how it comes into play with automation, code reviews, code coverage, and automated tooling. It's also one of those great stages where you can bring people from other teams, other different departments to talk about the idea or the changes you want to bring to life, whether it be you're updating a new README or you are essentially adding a new function to an application, right, to your code. And it gives you that ability to experiment without any risk. So once this pull request is created, we have a conversation around it, right? We review the code and improve as needed, but important to note here that Alberto is thanking Thomas for his review, right? By thanking him, he's speaking to him like a human. He's creating and fostering this welcoming environment, or this welcoming vibe, right? And that is very welcomed here. Empathy to speak to others, thank them for their time, and that really is at a core of how we communicate within GitHub. It really does go a long way, and especially since we're a software company, a lot of our communication, our medium is text-based. It's important to try to be as expressive as you can, whether through the use of emojis or through the use of emoticons, or just your language, right? That's very important. So, like mentioned in the previous slide, part of the discussion and review steps is for third-party tools to help with approval. And we try to automate as much as we can. In this picture, you can see automated test suite, which runs on server every time there's any changes pushed to our code base. This test suite includes unit, functional, integration tests, but there has to be a passing CI build before changes are deployed to GitHub.com, and this gives developers confidence and ensures code meets quality standards. So going back to our GitHub Flow diagram. Now, once we leave the pull request phase and everything's approved and we get a thumbs up, we want to deploy code from a pull request branch and merge only once it's been confirmed in production. So the latest main branch is always merged into the feature branch. It is our stable release branch, so everything on main is considered production ready code. If branch deploy ships bad code containing a bug or performance regression, it is then rolled back by deploying the latest main to production. So at GitHub, we will not ship code that has not been reviewed and that it's not passing the required build steps. Right? So when this deployment happens, it happens using our deployment APIs. And because of that, we have a historical record on the pull request itself that the code there, the code that went there, and ultimately, went to deployment, right? So we have that historical data, and it's important that lives inside the pull request. It provides that historical context and allows more people to know how this was done and why, right? And that's a crucial component within that pull request and the historical context of the pull request. Because now, 6 months from now, if someone joins the team and they look at that pull request, they can essentially kind of piece together the reasons behind this change or behind this approval or behind whatever was pushed through that pull request. But that historical data, that ability to self-learn and guide yourself backwards, right? To kind of discover your way or reverse engineer why a decision was made is very powerful and very important. So how do we even do that? How do we even deploy, code to GitHub, or how do we even essentially deploy, to production, right? Do we use a button? Do we just kind of just see what happens? But no, in reality, we use chat ops, right? And chat ops is the second step to our asynchronous communication and our shared common philosophy. So chat ops in general is basically chat operations. Within GitHub, we use Hubot. So if you haven't seen Hubot, you may be asking, what is a Hubot, or Hubot, but it's what is a Hubot? In this case, Hubot is our hardest working GitHubber within GitHub, right? And I think that's still true. It really does give the entire company it'll run for its money, right? Because Hubot is constantly always working, meaning that we're constantly always requesting or pushing commands to Hubot for any specific reason or not, right? So for example, if I want to do a .rem to remind, so Hubot can remind me of a link that I stored, or if I want to do a little bit more of a, foster some good communication and I want to show my appreciation to someone, I can do .sparkles and then that person's name. So basically I kind of give my, some kudos to that person, and in the back end, Hubot is doing his thing depending on what that command was. Some other Hubot commands, as we can see, for example, deployment, load balancer graphs to check performance, knowing who owns what service and what are the escalation paths if something were to go wrong, and instance and maintenance commands as well. So there's a lot of them, a lot of different commands, and it was kind of difficult to put them in a slide deck here, but yeah, a lot of different commands. Another example here is just Hubot commands in general. One thing that it's kind of easy to overlook is that by enabling or allowing people to type in these commands in a channel, it's really helping inclusivity and learning across the entire company. So by typing commands, people can see and help you if you don't type the command incorrectly. So it's a form of passive learning by watching others do it themselves. And I can say that from firsthand experience that I definitely learn some new Hubot commands whenever some of my coworkers use some of the commands that I'm not familiar with, right? And it gives me a sense of empowerment where I can go out of my way and put those commands myself as well. So it's a very powerful tool. And ChatOps is the cultural glue within GitHub. So in short, Hubot allows us to have a single point of traceability. It's auditable, and you may not realize it, but it gives you an ease of learning by having everyone do the work through Hubot. So now that you've gotten a taste of our workflow with pull requests and some of the review workflows, and you know what Hubot is, our magical robot, and some of these commands, how does it all come together, right? How does this, how does it all come together and deliver this continuous delivery aspect? Additionally, how did we go from GitHub, which was, was 10 years ago to what it is today, right? What were the lessons that we learned along the way? And it's also important to mention that GitHub is a monolith, so we do have those monolithic challenges associated with it as well. So at the very earliest, GitHub didn't have any deploy queues, any batch deploys, monitoring of deployments of the sort that we have now, right? You can deploy it through a chat, but you couldn't queue it yourself. And to handle deployment in chat, we had to control not overriding each other's work, because if you did, that would be bad for users, right? That would be essentially overriding someone's work without any consideration. So enter deploy locking, right? Locking deployment or locking deploy because someone has just deployed their branch and are not done with it yet is one of the approaches that we took in this case, right? To do this many deploys, you need to make sure that someone can't deploy over you by having a production locked. It's an old picture, but it still shows the actual feedback where you're trying to do a deploy, and then Hubot says, "Sorry, GitHub is in production, locked by," and then the person, right? And another thing to make sure is that when you deploy these branches, the branch gets updated if it gets behind. So here we can see Hubot is ensuring the branch is automatically up to date with main, or the main branch, right? This is an automation that is one of the big advancements, as you can see in how we've implemented branch deploy, during our growth in implementation here in GitHub. So locking deploys worked for a while, but as we grew and we grew, we started having additional challenges with regards to locking deployment. So we really needed a queue system, and we wanted to explore the ways of how we can change with queues as well. So before we even approached that challenge, we had to have some rules in place in mind, right? For example, main is always stable. Nothing should be merged into main before being deployed. If main contains bad code, fix it by deploying a branch that reverses the bad code, deploying it, and then merging it. Also, look at the processes around it, right? So you want to make sure that it passed the test, and you want to make sure that your coworkers get to review it, that you're able to deploy to front-end environments, And another component is that you want to take a pause, stop and think about the changes you're about to push, right? What would happen if something were to go wrong, right? Should this be feature flagged instead, feature flagged first instead, right? And lastly, deploy to a subset of live users, and then ultimately you deploy it everywhere. So we have a command here, which is .where can I deploy, and once these enhancements were made, we use a .where can I deploy to kind of understand what branches were locked, which ones weren't, and what type of environments I can essentially deploy to, right? And these are semi-isolated environments that worked off production code, which is an important fact compared to the way we do it today. Right? So deployment to branch labs, and a number of lab environments were available for testing, so they replicate various levels of production stack to balance speed and thoroughness. To deploy to the review lab environment, we can use .deploy, GitHub / and then my branch to review lab. And to test in different lab environments, replace the environment name with the chosen stack. So some of these caveats is that the lab environment do not receive any normal user traffic, but they do touch real production Git and real production databases. So your branch will cause issues if it creates bad data in queuing a job with change interfaces, or does something else the system running your code does not expect. So your branch must pass CI before deployment to the lab environment. And lab environments can also be used as to test non-staff requests, such as regular users, anonymous users, or community feedback, where we want to test something out. All you have to do is log into your normal account, and then use the necessary flags into your cookies to be able to try that out in the lab. So that worked for a while until there was so many people that deploying even to production, which is what we wanted. Ultimately, we had to implement a queue, right? We have to deploy to the production queue. After you're confident your changes does not and should not break any code, and you've gotten all the feedback and you've taken that into consideration, it's time to deploy to production Canary, right? As a mandatory step, we deploy to a Canary environment first. This environment is the minimal set of machines that reflects the front end stack. So one front end, one API machine, one file server pair, one worker of each type, and so forth. So if someone is testing on production when you're ready to deploy, you can be notified when it's your turn by joining the queue with .queue me to deploy, and then GitHub / my branch. So in this case, we can see an example here where Terabyte is executing that command as well. It's important to note that the Canary cannot be accessed or tested directly. The Canary's purpose is to prevent bad deploy from reaching every user. And you should not believe your change needs more testing at that point, because Canary is there to catch regressions you didn't find in the lab. So it tests everything you didn't change as well. So deployment to production Canary, 5 minutes in Canary was long enough to assume that a production deployment will not be a catastrophe. If you feel that your change is dangerous in Canary, or that you're blind to potential issues, consider adding metrics to the feature you're changing to track this in developer confidence graphs, right? You can watch the graphs in real time to make sure that there's no changes. And ultimately, if the Canary hasn't surfaced any issues, you can deploy to production. As I mentioned, this is typically a 5 minutes in Canary. And then using .deploy GitHub / my branch to prod will expand your deployments to all of production. So deploying to production works a lot like deploying to Canary, except that you can now verify your changes behaviors one last time to ensure there are no difference between a lab and production. So verify site behavior for 5 minutes while testing your change. So any part of your deployment fails, you can also find out who's on the call for deployment by running .who's on a call deploy and ping them to find out how to proceed, right? So as our team scaled, queue times got really long. And as you can see here, motivation to move beyond just a queue was high. So it's important to talk about this, because ultimately Really, it's the need to reevaluate what you've been doing regularly, right? So even though we went from from deploy locking to setting up our queue, it's important to consider and to continue reevaluating what you've implemented to see how you've grown and where you can grow from now, right? So by using this, in fact, this is a slide deck that I didn't show earlier, but here it says estimated wait time is about 3 hours and 19 minutes. So the queue time got pretty bad. So what was the solution? What was the next step? Boom, enter merge queue. Now at the time of this recording, it's something that we were experimenting with to create a new solution. If deploys were difficult before we had trains, it got worse when we added more developers to it. So this was an experimentation that we wanted to try out. To see on this slide a web interface for the merge queue. This was an experiment we tried to alleviate developer friction around October of 2020. And then ultimately automating the queue. So on top of having a better merging and queuing, our Canary deploys that we had been doing via chat ops previously targeted about 2% of traffic before rolling out to 100% of traffic in production, right? So this fails to catch a lot of bugs. So we wanted to increase the number of stage canaries from 2, 10 to 30 to better validate and roll out changes, right? But we didn't want to implement a lot of new canary stages and put unneeded stress and strain on developers and our system. So we thought about automating the queue, which is you can see here on the slide, right? However, let's jump into how we work today, right? So as GitHub, we have doubled the number of developers contributing to main GitHub.com application. And while it seems like a solely positive thing on the surface, the two times increase in folks contributing to the core software exposed some problems in terms of tooling. And tooling that worked for us a year ago, or perhaps tooling that we experimented with a year ago, no longer functioned the same way today, at its given capacity. So GitHub.com is deployed primarily through chat ops using branches, as we talked about earlier, using a deploy model. But as you can imagine, with the increase of an engineering team, the queue got larger, and the main Slack channel, once a haven for deployment, became overwhelmed with information, making it hard to track changes. So what happened, right? What was the next steps, and where did we go from then, right? So remember we talked about merge queues? Well, boom, we didn't ship it. We didn't widely ship this out internally, but we still, the experimentation is still in there. We're still iterating on it, but we've slightly pivoted off to a more of a evolved, progressive rollout. But first, before we even talk about that, it's important to have the problem in mind and set out a few main goals. So first, one of our first main goals was to simplify the deploy for developers. So one of the main issues that we experienced with the previous system was that deploys were tracked across a number of different messages within Slack channels. This made it very difficult to piece together the different messages that made up a single deploy. Sometimes there could be as many as a few hundred messages in between subsequent messages from deploy systems. However, with our Canary only pushing to 2% of GitHub traffic, there could be or would be a slew of other problems that would never get caught in the Canary stage build before we rolled out to 100% of production. And if we did, we would have to start an incident and roll back. To avoid this, and with availability and uptime at the top of our priority, we set out to introduce a second Canary stage, as you can see here in our diagram, right? And this diagram shows an automatic progression between a 2% Canary to 20% Canary, production deploy, and a ready to merge stage separated by automated 5-minute timers, right? So progressive rollouts. Second Canary stage at a higher percent so that we can catch more issues in earlier stages, which could reduce the impact of future incidents. In a progressive rollout, we can deploy to our first Canary targeting the first 2%, which aims to capture the majority of issues, keeping the risk profile at a tolerable level. As such, a small amount of traffic would actually be impacted by an issue, right? So rather than tracking down various messages in a noisy Slack channel, you can just go to a consolidated UI and you can see the state machine progression mentioned above in the overview to the right here, or the overview, the slide deck or the slide here itself, right? But it gives you that nice stage build, and you can see the rollout as it goes. And a little bit more with the second Canary stage. The second Canary stage again, introduced at 20%, allows us to direct a much more larger amount of traffic while still being in the Canary stages. So this has a higher risk profile, but it is mitigated by the initial 2% Canary stage and allows us to transition with less risk to the 100% stage. Right? And finally, the entire system can be monitored and started from Slack, just like before. We found that this is how developers typically want to start to deploys, following by monitoring in the UI component. So that iteration of always using Slack or Hubot commands to deploy stayed true, right? But it was getting a little unruly to view all of our feedback within Slack. So creating a UI component to it really was beneficial. And these changes have really revolutionized the way we deploy in GitHub.com, where confusion and frustration had once set in. We now have the joy and content at the use of an automated system. And we have received overwhelming positive feedback internally, and it's been very successful so far. And this is pretty much how we do it today. As we continue on, let's talk a little bit more about GitHub Actions. GitHub Actions is our automation tool within GitHub for both CI and CD. But what do we use GitHub Actions for, right? And that's a whole different topic on its own. We can go into hours talking about GitHub Actions. So I'm just going to try to keep it short and relevant in this case. GitHub Actions for project tracking. So within GitHub, we use project tracking to track almost everything, right? We use issues to track ideas and to track events or activities, and we also use our project boards. So it's a little bit hard to read, but first it checks out the repository, it checks out another repository, it then goes and generates the repository, and then it commits back into the first repo. So essentially, this automation is something you can do where you can kind of synchronize workflows, or rather work from or issues from one repo to another. It's not just CI, but it has its own workflow, right? And how the team is tracking its efforts is pretty much the art of the possible here. So you can get very creative in how you can use GitHub Actions to promote project tracking within GitHub. Another example here is that a prime example would be our roadmap project board, right? If you go to github.com/GitHub/roadmap, you can check out our upcoming releases with regards to features. But it's another great case scenario where we use project boards to keep track of work and automate communication between teams, users, approvals, and timelines. Right. And finally, enter code spaces, which is the full power of Visual Studio Code equipped with a new development environment for any size project in seconds with pre-built images faster than average laptops. In fact, we love and believe in code spaces so much that the whole engineering team has fully moved to code spaces. And there's a whole blog article behind this, but just kind of condense it. The goal behind moving to code spaces was to embrace the model where development environments are provisioned on demand for the task at hand, right? And some of the challenges here were moving our workload, from on-prem, or rather from our local machines to code spaces. So it started off, GitHub.com is about 13 gigabytes on disk. So simply cloning the repository takes about 20 minutes. And with the dependency setup, bootstrapping of GitHub.com in code spaces would ultimately take about 45 minutes to ramp up. So our first challenge here was, how can we change the way we work with code spaces? And by changing how code spaces clone GitHub/GitHub, we were able to also cache the network of software and services, and we brought our overall ramp up from 45 minutes down to 5 minutes. But we can also optimize a little bit more by using pre-builds, which allows us to create reliable pre-configured code spaces primed and ready for GitHub.com. Development now only takes about 10 seconds, and that is essentially the growth or the optimization from 5 minutes to 10 seconds. So we went from 45 minutes to 5 minutes, then from 5 minutes to 10 seconds, right? And new hires can now go from zero to a functioning development environment in less time that it takes to install Slack. And engineers can spin up off a new code spaces in parallel work streams with no overhead, right? But in summary, we leverage these trends, and your goal is to personalize the experience and content, right? So important here to find the talent and skills you need within your organization or from your community, right? Reduce new developers onboarding time by up to 40% by leveraging some of the tools that we talked about today, especially such as code spaces, right? You're able to just launch a new environment for new hires, a fraction of the time that it takes for that developer to set up their own environment in their own local machine, and really be a champion of open source and help your team work on open source code that they care about. Think about inner source, right? Bringing the open source philosophies internal to your enterprise. That's also really, really important. So what stayed and what evolved? So we didn't throw everything overboard. As we grow, and as we continue to grow, we experience some growing pains, and we really think about what makes what made that growth special, right? What was important to us, and as you can see, remote first and chat ops were at our core a very, very successful medium of how we work internally and at the fabric of our culture, right? The collaboration nature of chat ops has kind of replaced the casual conversation of a team setting, and you get the ability of looking over someone's shoulder to look at the graph. So it's much more synchronous in the sense that I don't have to ask or ask my colleague, hey, what are you doing? I can just simply look at the channel, and based on the commands that they've already inputted, I can just kind of piece together the work here, right? So what changed heavily? We changed heavily the architecture languages. We did flaky test detection and deployed train. So deployment to production are inherently an experiment. So any change to software is an experiment, but the system is huge. So it's so huge that it's important to think about, what type of changes am I bringing into the organization that can optimize how I can deploy code, right? And same with Canary deploys. When you're doing the same experiment, but you want to do it in small little pieces. You don't want to just jump into the pool. You want to make sure that it's the pool is not too cold, right? You want to make sure that small percentage of people don't have a negative experience before you essentially push it out to production. So with our new deployment model, 2% to 20%, and then ultimately to 100, and it gives us that flexibility to be able to experiment and to make sure that the user experience is not being sacrificed. And lastly, where we're headed. So we can break these down into 4 different pillars or themes, right? So we really want to focus on being contemporary, and within GitHub we have we really consider and talk and think about how we can bring the best developer experience possible to our users and to our developers who internally and externally. So contemporary is very important. A focus on modern tools, faster load and operation times. We want to be clear. We want to be intuitive. We want to have an intuitive pathway and next steps that are easy to follow. Noticeable connections to the wider workflow, the ability to get context faster. Users have all the information they need quickly. So, basically, be as clear and transparent as we can in how we communicate, right? Customizable. We want to be able to give you the sense that you can do anything, or anything is possible. You can do anything with any of these tools. Like for example, GitHub Actions, right? You can get very creative with GitHub Actions. You can connect these tools to any other GitHub offerings that you can optimize your full coding experience. So, you can use whatever you're comfortable with, and you can work the way you want to work, right? If your company or your team has this custom way of working, we want to make sure that you work in a way that helps you, and also provides you the ability to use GitHub at its full potential. And lastly, we want to be powerful. We want to be a central jumping off point for doing the work you need to do and launching into other workflows or experiences, right? A central place to understand everything happening with your code. So lastly here, we have some resources. You can start your free trial, 45-day trial of GitHub using Enterprise Server, or you can just use GitHub Enterprise Cloud as well. And you can learn more about GitHub on resources.github.com/devops. We also have the learning lab, so lab.github.com to learn more about GitHub. Just always feel free to drop by our community channel, or just reach out to any one of us from GitHub, and we'd love to talk to you. And again, thank you for this opportunity to share with you and of how GitHub uses GitHub and how we build GitHub, right? I love working here, and I love this company, and I love the tools that we make, and I'm so happy that I get to share that with you today. Great, awesome. Thank you, everyone. Take care, and have a blessed day.